Hello, Longhorns. This is Miss Clay. Today we will continue to talk about area, but today we're focusing on trapezoids, parallelograms, and triangles, and rhombi, and kites. We got a whole bunch to cover. So let's refresh what we talked about yesterday on our parallelogram. So the area of a parallelogram is the product of the base and the height. So remember the formula was area is equal to base times height. Right? Now the thing is, we notice this little drawing helps us because we know the base, remember, is on the bottom, and the altitude, also called our height, is right here. Remember, it has to be perpendicular to the base, means it has to give us a 90-degree angle. Well, if we look right here, we can turn the base a different way, and our altitude is right here. It has to be a 90-degree angle. So I rotated the picture because sometimes rotating figures for us helps us solve it better. So if we look at, here's our base. Now we can see that this, indeed, we have to draw this little imaginary line right here in order for us to be able to get our right angle and come up, and that will be our height, okay? So let's work on a couple examples real quick. So find the value of H for a parallelogram. So I rotated the picture and I put it up here so we have it. Remember, our formula is just area is equal to base times height. Now the problem is this time we're trying to find the height as opposed to finding the area. So if we look at our parallelogram, what do we have? We have base information. So we know those two would be the same. This would be 8.4, but we don't have our height. So also look, if we rotate this, this is actually our base, and we can make this our height. So we can say area is equal to base times height. And so we're going to plug this in and say area is equal to 5 times 8.4. So that gives us 42, okay? But we're not done yet. So now we need to figure out the H part of this, okay? Now we need to rotate or rearrange our equation. So we're going to solve for H. So we're going to have to move the B over here, right? So let's rewrite it. H is equal to A over B. So now we have the area, which is 42. And now we're going to use this base right here. And so then we can find this height. So we're going to use 6. So we're going to find out H is equal to 8. So I'll write it down here so that we know H is equal to 8. Okay? Let's move on to the next one. Okay, so this one we're going to actually work backwards because we have the area, and now we're trying to find the base right here. So see, we've drawn a little imaginary line right here to help give us our altitude or our height. So remember, our formula is area is equal to base times height. We need to find the base this time. So let's rewrite our formula. So base is equal to area divided by our height, which is right here. So we just plug in 14 divided by 3.5. And so that gives us 4. Don't forget the point. 0.0 miles. Okay? Remember, base is just going to be in miles. Area is in squared. All right. So let's move on to our trapezoid. Okay? So the area of a trapezoid is half the product of the height and the sum of the bases. So remember when we had our parallelograms or our polygons test that we talked about a while back? We have base. This is our base of our trapezoid, and this is also our base. Okay? So it's saying we need to add these two bases together, multiply it by the height right here, and then take the whole product and divide it by 2. Okay? There's our formula. So let's do some examples. What's the approximate area of Nevada? So look, Nevada is, okay, if you exclude this little tip right here, is in the shape of a trapezoid. So let's find it. I think this will be fun. So we'll be looking for the shape of Nevada. So sometimes if it helps, remember to rotate our trapezoid on the side. But here's our base. So let's call this one base 1. Let's call this base 2. And then 309 is going to be our height. I'm going to put H for height right there. So let's plug it into our equation. So area is equal to 1/2 the height, which is 309, times the base, which is 205, plus 511. So remember our order of operations. We need to add the two inside first together. So let's do that in one step so that we know it. So it's going to be 205. Oops, my calculator messed up real quick. Let's go back. It's going to be 205 plus 511. So this is going to be 717. And then now you can put this all in our calculator together. And you could have done it the other way if you wanted to put it all. Just make sure you use your parentheses so it did the order of operations correctly. Okay, so we get the area of Nevada is really big. It is 110,622 miles. And it's squared. Don't forget the squared when we deal with area. Okay. Let's go on to our next problem. Okay. So we can also use right angles to help us if we don't have the height for a trapezoid. See, in this particular one, we don't have the height. We know it's a right angle here, but we also know if we draw this right here, we also have a right angle right there. And so now we have, since it told us the angle was 60, we have a 30, 60, 90 triangle right there. So the rules apply. Now, also, if we cut this little trapezoid into pieces, if we know from here, from S to R is 5, well, this is a perfectly straight line. Okay, Miss Clay didn't draw a perfectly straight line, but if it is, then this length right here is going to be 5. So we could figure out this is going to have to be 2. 7 minus 5 is 2. So we need to find the height. So on a 30, 60, 90 triangle, remember I always draw the hypotenuse. So this is the hypotenuse. So we're finding the angle across from 60. So remember angle 60, the rule is equal to x radical 3. Well, this is across from 30. The 2 is across from 30. So all we have to do is plug in 2 radical 3. Okay, so we can turn that into a number we want to, or we can leave it like it is for right now. Let's leave it like it is for right now, and let's just keep solving it until we get the other part. Okay, so we can do that. So now we have the height right here. Let's erase this H over here. Okay, and so now we actually can put a value right here. So the value is going to be 2.3. And let's do it in the calculator just in case you all want to. So this is going to be 3.46. Okay. So now we can plug in our normal trapezoid formula. We have 1/2 height, which is either 2 radical 3 plus 5.7 plus 5.9 plus 7 together. So I'm going to do 12. So I'm just going to rewrite it using my decimals and my addition of my bases times 12. And so I'll get my total value is equal to 20.8. Okay. All right. Now for the next trapezoid, we need to find the base. For this time, we're given the area and we need to find the base. So we can say this is base 1 and this is base 2. This goes upside down. Well, and we know 5 meters is the height. So there's our formula up top, but we need to rewrite it, okay, so that we can have. So let's plug in what we know first. So sometimes that helps us. So I'm going to rewrite the formula and then I'll plug in the values that we know first. Okay, so the area is 21, 1/2 the height, and 6.2. And now instead of calling this B2, I'm just going to say plus X. Okay. So we did this before on some of our previous lessons. We have to distribute this through. So let's do that so we can all see. So it's going to be 5 times 6.2, which is going to be 31. And we're going to have to go 5 times X. We're going to have 5X. All right. Now I'm going to get rid of this fraction right here, like we've done in the past. I'll go 2 over 1, 2 over 1. So this is going to go away. So this is now 42 is equal to 31 plus X, 5X, I'm so sorry, plus 5X. Move that to the other side. So we're left with 11 is equal to 5X. So X is equal to 2.2 meters. Okay. Let's go on to our next topics. So we also have to cover rhombulus. Remember, if it's more than rhombulus, we say rhombuli. So if you see rhombuli, remember that's what it is. So this is rhombulus or kite. So they use the same formula. So isn't that awesome? Okay, the area is equal to 1/2 the diagonal of 1 times diagonal of 2. So look at our pictures. Remember on a rhombulus, the diagonals bisect each other. So if we look at this, we remember this side of the blue diagonal is going to be congruent to this side of the other side. And same thing goes for the red diagonal. These two sides are going to be congruent. So remember when we did our previous lessons, we said to make sure you do your tick marks to help you know what values you'd have before. The sides are also congruent for a rhombuli. So don't forget, all sides are congruent, just like a square, okay? Now, moving on to a kite. The diagonals are not congruent, and the sides are obviously not congruent, but these two are, and those two are, as we can tell from our tick marks, okay? And so we have this diagonal, diagonal 2 times diagonal 1, all right? So let's do some examples. Okay, so first one, find the area for the rhombulus. So remember what I said about our tick marks. So let's look at this. It tells us it's a rhombulus. So we know those two are congruent and we know these two are congruent. So let's call this one diagonal 1 and this one diagonal 2. So diagonal 1 is going to equal 12 plus 12, right? So that's going to be 24. And diagonal 2 is going to equal 15 plus 15. So that's going to be 30. So now all we have to do is plug it into the formula. 1/2 of 24, diagonal 1, times 30. And that gives us 360 meters squared. Okay, moving on. Next one. Okay, so sometimes we can find the area of a rhombus using a special right triangle theorem also. So this one says find the area of a rhombus. Now, this time we know the outside side, okay? Well, remember all of these are congruent. That doesn't necessarily help us finding the area, does it? We need to know the diagonals. So we know this diagonal and that diagonal are congruent. We will also know 1, 2, 3, this 1, 2, 3 are also congruent. What else do we remember about a rhombulus? When these diagonals bisect, we form a right angle. So now all of a sudden we have a right angle here. Remember that? We talked about that before. So now we can use our rules for our triangles. So let's draw this kind of triangle right here and see what we know. So this is a right angle. Well, we know this side right here is congruent to this. So this is going to be 4, and we know 6. So we need to find this side right here, right? So then we can calculate the full diagonal. So we need to find this one. So we can use Pythagoras' theorem for this one because it's a right angle. So we can go a squared plus b squared is equal to c squared. Okay, so remember our hypotenuse is across from our right angle. So we can go 4 squared plus x squared. I'm going to plug in the x for b is equal to c squared. Rewrite your formula. And you can put that all straight into your calculator. And what do you get? You're going to get x squared is equal to 20. So if we take the square root of that, we can either say it's 2 radical 5, or a lot of you all like to just put it in the calculator. We have 4.47. Okay, so that's the first part. Now we know this side right there. So in order to find diagonal, let's say this one is diagonal 1, and this one right here is diagonal 2. So diagonal 1 is going to equal to 4 plus 4. So that's going to be equal to 8. And now we know this value. So this one is going to be 4 plus 4, 7, plus 4 plus 4, 7. So now we're going to equal, diagonal 2 is 8.95. So I went out to the 100th place on this one, okay? So let's plug it all in. 1/2 times 8 times 9.85. And what do we get when we put all that in the calculator? Let me see. We have 8 times 8.95 divided by 2, and we get the area is equal to 35.8 meters squared. Let's not forget the meter squared part. Okay, next question. All right, so we can also use another rule also. So that one was Pythagoras' theorem. We can also use a 45-45 rule. Remember, this forms a right angle. This is congruent to this side. This part is congruent to this part. This time, they didn't even tell us the side information, the outside information, because we don't need it. We're not going to use it. So, but saying that, we know these two are congruent, so this is going to be 3. What are we going to know about this on a 45-45? On a 45-45 triangle, the two sides are congruent, right? So that means this right here is also 3. All right, so diagonal 1 is going to be 3 plus 3, which is 6. And diagonal 2 is also going to be 3 plus 3 is equal to 6. Okay, let's put it in. 6 times 6. All right, so 6 times 6 is 36 divided by 2 is 18. So I'm going to put 36 divided by 2, which is 18. All right. Now let's work on a kite problem. Okay, so we got the area of the kite. That's what we need to find this time. Okay, so look, these two are congruent. So we use the same formula. So we're going to call this one diagonal 1. So diagonal 1 is going to equal to 4 plus 4, which is going to be 8. And then now diagonal 2, right here, is going to be equal to 6.5 plus 2. So that's equal to 8.5, right? All right, now all we have to do is plug it in. 1/2 8 times 8.5. So that gives us 32 feet squared. All right. Okay, now that we've covered more of our shapes, let's do a composite figure. So a composite figure is kind of a combination of several different shapes together. Okay, so let's look at this. The hardest part about these is trying to figure out how to break them up. So looking at this first, we notice we have triangle right here. A rectangle right here. Give me. And then if we look below, we notice we also have another rectangle right here also. Okay, so far we have 2 rectangles. All right. Now let's see what we have next. Oh, well, right here we have a triangle, right? Okay, so that's a triangle. And then look on the other side. We also have another triangle. So we have 2 rectangles and 2 triangles. All right. So now let's work on solving our problem. Let's take it in pieces. Okay. Let's figure out our rectangle first. I'm going to kind of highlight them right here real quick, so we know about this guy. Okay, so let's find the area of it. So a rectangle, the area is base times height. So the base is 8. The height is 4. So the area of that rectangle is 32. Okay, that was easy. Now let's look at the other rectangle. So if we look at it, this comes down right here, and this is 4, comes over, oopsie, not that way, and comes up right here. So what do we notice about that? Now it tells us this whole base is 14, but if we look real closely, we'll notice that this rectangle right here is actually the same. If we go to this line right here, so this is 8 again. So actually we have 2 rectangles with the area of 32. Okay, so we have to remember that. We have 2 of these. 2 of these. Put 2 of these right here. Okay, so now let's work on our triangle. Let's start with this guy over here. Okay, so I'm going to form my right angle. So we know the height of the triangle, right? Remember our formulas that we need is 1/2 base times height for a triangle, but we don't know the base. So we can use Pythagorean theorem to calculate our base, okay? So I'm going to say this is x right here. So where I'm just going to say x squared plus 4 squared is equal to 5.6 squared. Or everybody remembers a squared plus b squared is equal to c squared. All right, now we can rewrite it where x is equal to 5.6 squared minus 4 squared. Plug that all in the calculator and we get 15.4. Now we need to get x by itself, so we need to take the square root of it. So we get 3.92. So that is the base of this value right here. 3.92. So now we can use that to calculate the area. So 1/2 3.92 times 4 for the height gives us a total of 7.84. Okay, so this is our left triangle. Put a little symbol right there, okay, for us. All right, so we got one more triangle. So we got our 2 rectangles. We got 1 triangle done. We need to do this last one. So let's draw a little imaginary line right here and a right angle. So if this height is 4 over here, that means this is 4 over there. Okay, so just like the other triangle, we need to find the base. Okay, so I'm going to call this x. We've already solved for x, but we'll just call this one x over here. So let's do this one over here. This is going to be the right triangle. Okay, so x squared plus 4 squared is equal to 4.5 squared. That's our hypotenuse. Let's rewrite it where we have x is equal to 4.5 squared minus 4. So we put that in the calculator and we were going to get x squared is equal to 4.25 and take the square root of that. We get x is equal to 2.6. All right, so now we need to find the area for this one. So let's put area over here. 1/2 base times height. So let's plug in. We have 1/2 2.06 times 4. And so that gives us an area of 4.12 feet squared. Now we're not quite done yet. We need to add all of our components together. Let me tick off our triangle that we got it. So let's look and see where we are. So we have two 32s. So the area of our figure is going to be 32 plus 32 plus what was the area of our left triangle right here? Plus 7.84 plus our right triangle is right there, 4.12. So we get a total of 76 feet squared. Okay, we'll do more of these as we go, but that's off to a good start. Please talk to your teacher if you have any questions. Bye for now.